Now let's have a look at example 4. Example 4 is asking us to solve the simultaneous equations 2 times log x equals log x plus y, and secondly log y is equal to log 2 plus log x minus 1. Okay, something to note here is that the bases are not specifically mentioned, but because there's no base, we assume the base to be 10, or the common log. Okay, so the base of these logs is all 10. Also, a couple of things over on the side there, you'll notice it says that x must be greater than 1 and y must be greater than 0. Now that just to make sure that there's no log of a negative or a 0. So we won't have, if you put in 1 here, we end up with a 0. So we're going to ensure that this is going to be log of a positive number, and over here this will be the log of a positive number. We'll look at what we need to do. What we need to do in this type of question is we need to get a single log on either side, and then we're going to compare their arguments in both of those equations. Okay, so the method here is to get a single log on either side of the equals, and then we're going to compare their arguments. What do we mean by arguments? The arguments are simply things in front of the logs. Okay. Alright, let's look then at the first equation. It says 2 times log x equals log x plus y. Now you might think that there's a single log both sides here, but in fact this 2 times is a problem. Okay, we cannot compare the arguments when this guy's being multiplied by 2. This is 2 log x equals log of x plus y, so we can't compare the arguments just yet. What we need to do is apply the law that 2, being a number multiplied outside, goes on to the power here of the argument. Has its own law. The 2 goes up on the shoulder there of the x. Right, and on the right hand side then we have log of x plus y. And now what we're going to do is we're going to compare the arguments. So we've got a single log each side, so we can find those logs and just compare the arguments and say, well, x squared on the left must equal x plus y on the right. Okay? And that is our method for the first equation. So let's go to the second equation and do the same job. So log of y equals log of 2 plus log of x minus 1. So this time the problem is on the right hand side of the equation. There's a plus and there's 2 logs. Remember, the same base. That 2 should be a bit bigger. That 2 should be there. So log of y is equal to log of 2 plus log of x minus 1. They're all logs of the same base. And what we can do on the next line is we can bring those 2 logs together as a single log by multiplying the arguments. Okay, so we have a single log now on either side. Single log either side. Next step is to compare the arguments. So over here I will say, what's the argument of the log on the left? It's y. And the argument of the log on the right is 2 times x minus 1, which works out as y equals 2x minus 2. Alright, so we've completed that step for the second equation. We've got 2 equations in x and y. So the next step would be to solve both of those now to find x and y. Alright, let's go ahead and do that. First thing you notice is that one of them is a linear, one is a non-linear. This guy up here with the square, he's a non-linear equation. So what we'll do is we will get a letter on its own from the linear. Now that's already done for us because we already have y on its own. So we can get y and sub this expression for y, sub y, which is now 2x minus 2, into x squared equals x plus y. Okay, so instead of y, I'm going to write down 2x minus 2. So x squared is equal to x plus, I'm going to sub in, it's a different color there, just to sub in 2x minus 2. And let's run through this. What do we see then? We see that x squared is equal to x plus 2x minus 2. Okay. Come down here a little bit. And we'll just get everything to one side. X squared, now these two come together to get 3x on the right hand side. They'll become minus 3x on the left. And we'll be adding 2 onto both sides to get 0 on the right. Okay. Now can these factor? Let's have a look. See if they factor for us. X squared, so that's x times x. Now 2 and 1, the only factors there are 2 and 1, so look at the negative in the middle there. It must be negative 2 and negative 1. So in one world we have x equals 2, in the other world we have x equals 1. Okay? Now remember, from 2 up here, I know that y is equal to 2 times x minus 2. So it's 2 times x minus 2. I'll just divide that world up a little bit more. So y then is equal to 2 times x minus 2 in both of those cases. So we'll just sub in. This guy goes in here, and goes in as a 2. This guy goes in here and goes in as a 1. Now we can work out what the y numbers are. 4 minus 2 is 2, and 2 minus 2 is 0, so y is equal to 0. Okay, so x is equal to 1, and y is equal to 0 there. Okay, so let's have a quick peek back up at the question. We're told, remember, that y must be greater than 0. Oops. Y must be greater than 0. So let's have a quick look back up at the question. We're told that x is greater than 1 and y is greater than 0. So let's see, what do we have? X is greater than 1 and y is greater than 0. So the only one that satisfies that is this set of solutions here. Y has to be greater than 0. So even though it's a valid solution to our quadratic, it doesn't satisfy the conditions of the question. So our final answer there looks like this. X equals 2, y equals 2. I'm going to leave it to you guys to check that answer by subbing into the linear equation again. Okay.